Welcome to the Birkbeck Babylab. As the name suggests, at Babylab we study babies, of course. Now, for psychologists, studying babies is quite a big challenge because, of course, they can't understand verbal instructions. We can't tell them what to do. They can't reply to questionnaires. They can't write, of course. And so we have quite a big challenge to understand what's going on in the infant's mind or brain.
It's an international multidisciplinary centre that kind of combines high technology to understand what's going on inside your baby's head.
Infancy is the most crucial time. It's when the brain changes the most. It's when the brain is also the most plastic. So we really need to understand that period.
So one of the trickiest things about studying babies and their development is that babies at very young age, they can't speak, they can't move much, so there's very limited things that we can test by just looking at their behavior. Whereas by using methods like this, we can look at their brain activation directly and study abilities before they can actually express them. So the way it works is we know that our brain cells talk to each other by very faint electrical signals, and the sensors that we place on the baby's head pick up this activation. So the nets that we use are specially designed for babies, so we have different sizes for every baby head size. This is what it looks like. It's basically an elastic hat that we just stretch out and put on the baby's head. Each sensor has got a sponge inside, which we soak in warm water with a bit of baby shampoo and salt beforehand, so they're nice and soft and warm against the baby's head. And we entertain the babies with some bubbles and things like that. So while these nets might look like something from a science fiction movie, they're perfectly safe, so there's no risk associated with using these nets. All the sensors do is record the activity that comes out of the brain, but they can't change it at all. So it's like a thermometer that measures the temperature but doesn't affect it at all.
Here at the Babylab, we use various behavioural assessments which look at how babies interact with people and play with toys. One of the advantages of using this type of assessment is, unlike a lot of the methods that we use here at the Babylab, which involve static, still photos or videos of things, this is looking at the baby in a more naturalistic environment, so we can see how they behave naturally and also see how that behaviour changes in different situations. One of the assessments that we use, and it's one that we use actually on our Baby SIBS project, which is a longitudinal study of children who have an older sibling diagnosed with autism. We see them roughly every 6 months, so they come in from 4 months up until they're 3 years old, and we carry out this particular assessment which looks at their development each time they come for their visit. We look at things such as their motor skills, both gross motor and fine motor, for example, whether they can stand on one leg or jump down from a step, how they grasp objects on the table when we're playing with them with toys, and we also look at their language abilities as well, whether they're babbling, whether they communicate with the researcher, how well they understand what the researcher is saying, things like that. And it's nice on our longitudinal study, we can get a very accurate picture of how they're developing over time.
So two of the more new technologies that we have here at the Babylab are called Surface EMG and Motion Capture. And these are really great tools that we haven't previously been able to use with infants until the technology became advanced enough that they're now wireless. So Surface EMG uses these sensors to which we've got connected just paediatric electrodes. And all we do is just place them on the skin, they're just like stickers. And that will then wirelessly transmit a signal, and that signal just simply tells us how the cells are communicating to each other. So for example, if we put sensors on the arm and then the baby reaches for an object, we can really accurately measure their reaching behaviour. Even to the point where even if you can't see them move, but they're just anticipating a movement, we can see that as well. So that's really exciting and looking really precisely at movement. And the other counterpart to that is motion capture. And motion capture is the same as Hollywood used to make CGI characters all the time, and they're basically just these silver balls which are highly reflective markers. We have super high definition cameras that can detect the reflection of the light from the silver marker back to the camera. And in doing that, we can really accurately track movement. So if the baby wears one of our little jumpers, and then if they wave their arms around, we can really accurately track the movements.
One of the techniques that we use at the Center for Brain and Cognitive Development is eye tracking, which allows us to see exactly what the baby is looking at, either on a screen or in a live scene. Tracking babies' eye movements can tell us a huge amount about cognitive processing and is a fast and detailed tool for assessing the early abilities of babies. Eye tracking uses non-visible infrared light to create reflections on the cornea and pupil of the baby's eyes. And a camera in the eye tracker detects these reflections, and the computer can calculate the exact position of the eyes on the display that the baby is watching.
So this is the near-infrared spectroscopy headgear that we use with the infants here, and it's been specially designed so that we can fit it on very fast and very quickly, and it's comfortable as well, so the babies don't really notice it when it's on their head. So if you have a look at the array here, we have lots of optos, one after the other, and if you look on the back, what happens is these optos are either source lights or detectors, and these work in pairs together. So the light will go a little way into the head, and when it reflects back out again, we're able to read this, and it will change colour according to the colour of the blood. So if the blood is more red, it means there's more oxygen in there, and that means that that part of the brain is more active. So if you look at the whole hat, we're able to get an array of different colours according to which part of the brain is active. And this is ever so easy to put on. You just place it on the baby with the Velcro at the back and a little ribbon that goes under their chin, and then they're just free to watch the stimuli, whichever thing that we present to them.